Jai Hind to all. My name is Dhanshri Parihar, Assistant Professor, Department of Computer Science and Engineering, Akgec Engineering College. And my today topic is mode of transmission from the subject Computer Organization and Architecture. So, the content of this presentation include peripheral devices introduction, what are input-output interfaces, how the input-output devices are connected through an interface to the central processing unit. Then we have types of data transmission, where we will be discussing asynchronous data transmission along with some brief description of synchronous data transmission. Then we have modes of transmission and the types of interrupt, where we will be discussing the priority interrupt. Then we have a transmission access using direct memory access. And then we have a introduction of input-output processor and what is a serial communication and why it is important in input-output devices. Now, what is a peripheral device? A device that are under the direct control of a computer are said to be and are connected one line are known as your peripheral devices. In short, the input-output devices will be named technically as a peripheral devices. So here we are having three types of peripheral devices. One is the input one, through where we can insert the data into our computer system. And the second one is the output peripherals, where the data can be received as an output. So those devices are known as the output peripherals. Then we have input-output peripherals, the devices which will be acting at the same time as an input device and as well as an output device. For example, we will be having a touch screen. So whenever we touch our screen panel, it will be acting like an input device and the outcome of that touch will be acting like an output peripheral device. So that is an example of input-output peripheral device. Here we are having some examples of these peripheral devices. Like monitor, we are having the keyboard we are using to insert the input, and then we have a printer to create a hard copy of our device on our device of our content which is inside of a computer system. Then we have a storage devices like magnetic tape, magnetic disk and optical disk. So how these input-output devices are organized in the system? So in short, we are using the ASCII codes for the characters which are on our keyboard. ASCII code stand for American Standard Code for Information Interchange. So like we are using this 7 bits of code for 128 characters. 94 are printable and 34 are non-printing. So the 7 bit of code is from 00 to 7F, and these codes are used to represent the characters, that 128 characters. So this is that symbolic chart of how these characters are being represented in a form of ASCII code and a binary representation of these codes. Now next is very important, input-output interface. Now what is an interface? An interface is a kind of a unit which will provide the interaction between the CPU, that is the central processing unit, and the input-output devices connected with our computer system. So it will be acting like a mediator between the two. Now what actually is an interface? It will resolve the differences between the computer and the peripheral devices, as I tell you, and it will be a method for transferring the information between the internal storage and the CPU, that the external devices. So what are the tasks which will be performed by these input-output interface? One is the connectivity of the peripherals with your CPU and the data transmission between the CPU and the input-output devices and the input-output devices themselves. Third one is the format of and the unit of information transmission. That will be in the form of a byte or a block from CPU or from the memory to our connected input-output devices. So memory is a different thing and a CPU is a different thing, and an input-output device like a monitor, keyboard, mouse, so their connectivity will be organized with the help of these interfaces. Now let's have a look at this diagram. Here we can see clearly that we have a processor over here, that is the CPU, central processing unit, and which is connected via 3 buses. One is the data bus, then we are having an address bus and a control bus connecting these interfaces as an intermediate between the CPU and our input-output devices. Like we are having the keyboard connected over here, printer, magnetic disk and magnetic tape. Now, what is the role of this interface which is connected as an intermediate between the two? So the first one is it will decode the device address that will be put on the address bus. That is the one task being performed by the interface. Second is it decodes the command and the operation which will be for what purpose the code has been or what address has been inserted on the address one belongs to which unit. And the next one is it will provide the signal for the peripheral control. So what kind of operation have to be performed, either reading operation or a writing operation. So that control signals are also being connected with your interface. Then we have the synchronization of the data flow and the supervisions. So these are the tasks which is being performed by the interface inserted in between the processor and the input-output devices. So it will be basically having 4 commands. First is our control command, which is used to issue and to activate the peripheral and to inform what to do. Next is for generating this command is generated on the control lines. Whenever the CPU want to interact with any one of the input-output device, it will insert an address on the address bus. Okay, and that address will move to all the interfaces connected in the circuit like this. So it will be checked for the address for which particular device it will belongs to, and that channel will be opened by that interface for that device, and the other will be rejected because that address will belong to some particular input-output device. So other will not be accepting that address, and the channel will be open, and then the data which is transmitted by the processor on the data bus is being transferred to that particular device. Either it will be taken from that device or either it will be given as an output to that particular device. Now, what is the role of this control signal? Either it is used to read the data, write the data, memory read, memory write, bus grant, bus request. So these all signals are our control signals which is being processed on our control lines. Okay, so that is a control command. Next is our status command. Now, what is the role of this status command? It is used to check the status of an interface. It means that whether that the data which is inside the interface is available for transmission or not, which we'll be discussing later on in detail. Now, next is the data output command, which will cause the interface to respond by transferring the data from the bus into one of its registers. So, data command is used to, there is one data register inside your interface. So, whether that data is being put in that data register or not, so that for observing that this data command is being used. That is the data output command to take the data from that data register inside the interface, and this one is to input to insert the data inside the data register that will be placed inside the interface. So interface is nothing, it's a combination of a flag, that is a status bit used to check the status of data register, and one data register is inserted inside it, inside the interface. Now next is what is the role of these buses which are being used to make a connectivity between the this CPU and the input-output devices. So what is the function of these buses? Like we have a memory bus. It is used for information transfer between CPU and a memory unit. Similarly, we have an input-output bus that is used for information transmission between the CPU and the input-output device. So when the data transmission occur between a memory and the CPU, then we will dedicatedly name it as a memory bus. And whenever the data transmission occur by using all three those buses, address bus, control bus and data bus, we will be naming it as a input-output device. Okay, so there are 3 ways to organize the buses. These buses, the control bus, the data bus and address. So there are 3 basic organization schemes which can be used to connectivity of these 3 buses, how they can be connected in different organization schemes. So first scheme of organization is to use the 2 separate buses. Okay, so by using the 2 separate buses, what we can use and one for the communicating with the memory and one for the input output. So it means that the one way is either we can use a set of these 3 buses differentially for this printer and keyboard. They will be having a separate set of these 3 buses, and again the memory, that either be primary or secondary, they will be having a different three buses set for themselves only, solely be used by it only. It will be not in a shared mode. As shown in this diagram, this organization is in a shared mode. So they will be occupying their own three buses, the keyboard and the printer, like these input output devices, and the memory will be occupying its own three set of bus, address, data and control bus. So one way of organizing the buses is like this, to use the two separate bus organization scheme. Next is to use one common bus for memory and input output, separate the control lines. So the another scheme is what we can do, that we have a processor and we are using a data and address bus. So we are connecting the, suppose there we are having an input device and output device, and here we are having a memory. So they will be commonly using it. We are having an interface in between like this. Okay. So commonly they are using the data and address bus, but they're having their own control bus, separate control buses like this. This will be having its own separate control bus. Okay. One way of organizing common data and address but separate control bus. And the third scheme is use one common bus for memory and input output with common control lines for both. Here we are having, this scheme is known as the memory mapped organization scheme. Here we are having a common control lines. So let's have a look over it. So this one is where the memory and the input output devices are using this address, data bus and control bus commonly, but they are having their separate set of instructions. So, and this one is isolated scheme. It is a memory mapped scheme of bus organization and data transmission. Here we are having a separate set of control lines for both memory and input output, but having common address and data bus. So that one is the isolated input output scheme, and the second one is memory mapped input output scheme, which we have already discussed. So this is the detailed discussion about the bus organization along with your memory, input output devices and your CPU. Now next is the asynchronous data transmission. So what is the data transmission? Data transmission means how the data is being moved from the CPU to the devices and from devices to your CPU. So we are having two schemes for it. One is the synchronous data transmission scheme and another is the asynchronous data transmission scheme. Here in this, so next is the data transmission scheme. So we are having two types of data transmission scheme for input output devices and CPU. One is the synchronous data transmission and the second one is asynchronous data transmission. So in this slide, we will be discussing only the asynchronous data transmission. But what is the synchronous transmission? In synchronous transmission, we are using the clock pulses and that will be applied along with the resistors and the different units which is connected together, and on the measure of that clock pulse, the data will be simultaneously transferring. But in asynchronous data transmission, the internal timing of each unit is totally independent and each unit having its own private clock. So we are not using a common clock to have a data transmission between the two units, but a single unit having its own clock whenever it will be working in itself. But whenever the data is being transferred from one block to another block, there will be no common clock pulse inserted to them. That kind of transmission is known as asynchronous data transmission, and we are having two types of asynchronous data transmission technique. One is the strobing technique and another is a handshaking technique. So in a strobe kind of transmission, we have one source unit and a destination unit. So this block diagram is for source initiated strobing for data transmission between the source unit and the destination unit. In this scheme, the data transmission is initiated by the source unit. So whenever the source unit want to send the data to the destination, it will put the data on the data bus and then get this strobe signal. It will put it to in a high mode. Whenever it will be in high mode, the destination unit receive this signal, that is an indication to receive the data from your this data bus, and that data which is available on data bus is a valid, and it will start receiving the information or the data from the data bus. So it is a source initiated strobing for data transmission, in which the source will be putting the data and activating this strobe signal. The next kind of data transmission is destination initiated strobing. In destination initiated strobing, the destination unit will send an indication to a source unit by using a strobe signal, putting into in a high mode, and then that indication is being received by the source unit to put the data on the data bus. So in reply of that strobe signal, it will be putting the data on the data bus, and data is being received by the destination unit, and it will till it will be valid, this signal will be high, this strobe signal will be high, the data on the data bus will be considered to be a valid signal. Whenever this strobe signal will falls down, it will become 0, the data on the data bus will become invalid, and the destination unit will stop receiving the data from the data bus. And this is the timing diagram for this. So it is a destination initiated strobe for data transmission. So but this strobing is having a drawback with it. So what is the drawback? There is no way by the destination unit to know that whenever to receive the data, whenever it will send an indication to a source unit to get the data being transmission to be stopped by the source unit. So there is no source of kind of acknowledgement from the side of the destination unit to the source unit to stop receiving the, that it is not now ready for receiving the data, or it do not want any data transmission. That indication is totally missing from this kind of scheme. So in place of this scheme, another scheme is introduced that is known as handshaking. Now in the handshaking scheme, we have the third kind of signal over here also, that is the data acceptance signal. So that is a kind of an acknowledgement from the side of destination unit that whenever it is receiving the data and it's not willing to receive more, it will put this signal to be high, in a high mode, indicating the source unit that now I will be done with the data and it will be being accepted. Now no need of putting any data, no more data on a data bus. So let's have a look on this scheme. So it is also of two types, source initiated and destination initiated. In source initiated, the source unit will be putting the data on the data bus and just putting this data valid signal to be in a high mode, indicating the destination unit that the data which is available on the data bus is a valid data and you can receive it. So whenever this destination unit complete it receiving of data from the data bus, it will send in response an indication to the source unit indicating that the data has been accepted now. So there is no need of putting the data on the data bus now. It will be putting it to be high when it will complete its transmission. In response, the source unit will put this data bus to be down mode, data valid will be crossed, and no further data will be sent to the destination unit. So this is a kind of a handshaking kind of scenario in which the acknowledgement from the destination unit is being sent to the source unit for no more receiving the data. Okay, but it is a source initiated handshaking protocol. We have a, this is the timing diagram for this. Data valid is there. Whenever this high, data valid is high, the data bus is activated, and high means from here we are start receiving the data till this downfall of a clock pulse. And this is the acceptance, it is accepting, and whenever it will be crossing, it will be not accepting any data. That is an acknowledgement signal. Now this one is the destination initiated transfer using the handshaking. Now in this type of transmission, the first initiation of transmission of data between the source unit and the destination unit will be initiated by the destination unit now. Now, first of all, the destination unit will put this ready for data in a high signal mode, indication to the source unit to put the data on a data bus. So it will be requesting source unit that send the data to me, and in response, the source unit will be putting a data on data bus. So that data bus is now become a valid data when this signal will become high and the destination unit will start receiving that data. Whenever the destination unit do not want to receive the data, it will be keeping this ready for data signal to be in a zero mode, and is an indication to the source unit that no more data will be needed by the destination unit. So difference is between the initiation. In one case, the initialization of transmission is done by the source unit, and in the another case, initialization of transmission is done by the destination unit. So these are the our handshaking and strobing type of asynchronous data transmission. So if the return of handshake signal does not respond with a given time period, the unit assumes that the error has been occurred. So here, as we are knowing that it is an asynchronous type of data transmission, here we are not inserting a clock for transmitting the data, a common clock pulse for transmission of data between the destination and the source unit. So here we will be assuming some particular period of a time, that for this period we need to come. Suppose we are assuming that within a 10 second the data need to be transmitted. If it is not transmitted within a 10 second, so that will be assumed as an error for this asynchronous transmission. Now next is modes of transmission, which is actually the basic topic. So here we are having what is the modes of transmission. The binary information received from the external device is usually stored in your memory, and the information transferred from the central computer is also an external device originates that will be found in our memory unit. So CPU merely executes the input-output instruction and may accept the data temporarily. So data transmission between the central computer and the input-output devices may be handled in a variety of types. Whenever the data is transmitted between the CPU and input, as we already discussed, the interface is there to handle that transmission. So that will become under this programmed input-output. So we are having three types of data transmission scheme. One is the programmed input, another is the interrupt initiated input-output, and the third one is the DMA, direct memory access type of transmission. So let's have a look at programmed input-output, first mode of transmission. As we can see here, we have one block in between, which is known as an interface. So this is the detailed diagram of this one that we have previously discussed. This, the first diagram, this one. So now we are talking about this interface, how it will be actually working and used for transmission between the processor and the input-output devices. So let's have a look, and this will come under the programmed input-output data transmission. Okay, so here we are having interface which is composed of two parts. One is the data register, another is your status register. Now status register is a flag which will be holding only the one bit of data, either 0 or 1, indicating that if its value is 0, it means that the data in the data register is not a valid data, or there is no data available in your data register. And 1 means the data in the data register is a valid data and we can receive it. Now it is available data and that can be used for transmitting further. Okay. So what will be happening in this transmission? We have a CPU, we have an interface, and we are having an input-output devices connected with that particular interface. So we are having four type of connectivity over here. One is the data bus, address bus, and here we will dividing this control bus into two parts. One is the input read and another is your input write transmission. Again here the input output devices are having the three connection with it. One is the input bus connection, another is the data valid signal, and third one is the data accepted signal. So whenever the input output device need to transmit the data with the CPU, or the CPU wants to send some data to your input output devices, it will first put that indication on the input output device, indicated that it wants to send the data either to the CPU or it is ready to receive the data from the CPU. So first it will be sending the signal to this input output bus, and this indication will be to the interface. Okay, so read the data register, then the CPU will be reading the data from your data register, either the data is available in data register or not, and then the flag which is checked whether it is 0 or 1. So this CPU is keep on looking for the availability of data in data register, which is being put by the input output devices in it. If the data is available, then data is being transferred from the data bus to your CPU. If data is not available, then the data is not transferred. So again and again, the CPU need to perform a check on this interface for the availability of data in a data register, for which it have to have a check on this flag bits. Okay, if it is 0, then again you have to read the data register. If it is 1, then read the status register. So the transmission of data to the memory will be done if the data is available and the CPU will be receiving. Either it will be receiving or sending. The address will be put on the address 1. Like this is only the one input output. There will be the multiple input output devices connected with it. One will be sending the data, another will be receiving the data. It can be happening in this structure. So that is not shown over here. It is a common, we can say, term used for indicating all the input output devices. So when the data is being received by the CPU, the address is of that different input output devices being put on the address bus to transmit the data, and whether it want to perform a read operation or write operation, it will be indicating by putting a high signal on that particular line, and the data is being written to this data register and being again overridden or read from here, and is being transmitted. Okay, either received by, so this input output device is now in a sending mode. We can have an input output device which will be in a receiving mode, receiving of data from your CPU. So whenever it will be sending, input output bus is putting the data on data register, that will be put on data bus and received by the CPU. The address of next where it want to transfer will be put over here, and the data from data bus will be transmitted that input output devices. So when this transmission is completed, the data acceptance signal will be put on a high mode, and then it will be indicating input output device that the transmission is now successful. So this is how our first programmed input output will work, where the interface is playing a major role in this transmission. So it's good for today. Thank you and Jai Hind to all.